Alright, so today we're going to talk about complex rational expressions. Alright, so first I want to relate it back to a complex fraction. So a complex fraction is a fraction in which the numerator, denominator, or both also contain a fraction. So an example would be 1 over 4 over 5 over 8. Okay, so you might remember this. Okay, and we have talked a little bit about it in the dividing video, because it's another way to write divide. So it's saying 1/4 divided by 5/8. We're going to do the keep, change, flip. Okay, so you're going to keep the 1/4, change division and multiplication, and flip 5/8 to 8 over 5. And then we follow multiplication rules. Reduce down. 4 and 8, that goes to 1, 8 goes to 2. Because 4 can go in 8 2 times, and 4 can go into 4 1. So then it's going to be 2 times 1, which is 2, over 1 times 5, which is 5. Okay? Now, when you're doing this, you've got to make sure it's a single fraction over another single fraction. So, for example, if you had 6 and 1/3 over 9. Okay, you would have to get this 6 and 1/3 as a single fraction. So that's just where you say 6 times 3 is 18. 18 plus 1 is 19. So it's 19 over 3 over 9. Remember how to make a whole number a fraction? You put it over 1. So there's your fraction and your fraction. We're going to do the keep, change, flip. So we're going to say 19 over 3 times, flip the 9 over 1 to 1 over 9. Nothing can cancel. So it's going to be 19 over 27. And that's your answer. Okay, so we're going to do the same thing, except now we're going to talk about a complex expression is in which a complex fraction contains a variable. Sorry about that. So a complex rational expression is when a complex fraction contains a variable. So it's when these guys have letters with them. Okay, so steps. Step 1 is create a single fraction, kind of like we did up there. You might have to get like denominators and like smush some stuff. Okay, so it's if necessary. Then you're going to do your keep, change, flip, factor if necessary, cancel out common factors, write new simplified expression. Okay, so let's do one. So the one you previously have seen, we did one like this, something similar to it. Okay, so they're both expressed as a single fraction. So it's going to be 2 over x times y over 1. We did the keep, change, flip. Okay, so now we can't solve any like factors. We don't have any, so it's 2y over x. Alright. Alright, so the next one is going to be 3 over x plus y all over 4. So again, make sure they're both expressed as one single fraction. Well, this one is on top, the numerator. But the denominator, we're going to do like we did up here with the 9, and we're going to put it over 1 because it's a whole number. Now it's expressed as a fraction. So then we're going to do our keep, change, flip. Keep the numerator, change to multiplication, flip the denominator. There's nothing you can factor, there's nothing you can cancel, so we just smush. We're going to have 3 over. You can leave it like this, or you can say 3 over 4x plus 4y. Okay, either one will be an answer. Alright, so number 3. Let's go to the next page. It's going to be 3 over 2 over x plus y. So, neither one of them expresses a single fraction, okay? I mean, 3 is, but I'm saying put it in fraction form. So to put a whole number in fraction form, we say 3 over 1. Now this denominator right here, you're going to have to get, this is one fraction. So look over here. We're going to treat it like an adding irrational expressions. Okay? Just like we did, I think 2 lessons ago. You're going to put the y over 1. So 1 and x are your common, right? So I'm not going to multiply that side by 1. Then we'll multiply this side by x over x. And then I get 2 over x plus yx over x, which is 2 plus yx over x. Okay, that's exactly what we did in our last lesson. Okay, I smushed the top, smushed the bottom. Well, the bottom had a common denominator. Okay, so now this can be rewritten as 2 plus yx over x. Now we're going to do the keep, change, flip. Keep, change, flip. Nothing I can cancel out. Okay, so my answer is 3x over 2 plus yx. Okay, so that combined in a previous lesson of adding rational expressions in that one. But that's what I mean by expresses one common fact, or one fraction on top and bottom. Alright, number 4. It is going to be 3 over x minus 4 all over 1 minus 2 over x minus 4. So the numerator is expressed right. But the denominator, you need to come over here again. And we need to do some subtraction rational expressions. So when you're subtracting, you do the keep, change, change. So it'll be 1 plus negative 2 over x minus 4. You can turn that 1 into 1 over 1. The common denominator is x minus 4, so I need to multiply this side by x minus 4. And I get x minus 4 over x minus 4 plus negative over x minus 4. Smush the numerators, and I get x minus 4 minus 2 over x minus 4. You can simplify that to x minus 6 over x minus 4. So that is what this is. Now we can do the keep, change, flip. Keep, change, flip. And we do have some factors we can cancel out here. X minus 4, x minus 4. And then we're left with 3 over x minus 6. And that's your answer. Alright, so the next one, oops, number 5. Okay, number 5 is going to be x squared over 32 minus 2 over x over 16 minus 1 half. So this one you need to work on both the top and the bottom. Okay, so let's just do it vertically, I mean horizontally, right? So 2 is really over 1. So 1 and 32, well, 32 can't go into 1, but 1 can go into 32, what? 32 times, so you can multiply this side by 32, right? You get x squared minus, that'll be 64 over 32. Okay? All over this one. 16 can't go into 2, but 2 can be made to look like 16 by multiplying by 8. And you'll get 8x minus 8 over 16. Okay? Now, we're going to do the keep, change, flip. So we're going to keep the x squared minus 64 over 32. Change division and multiplication. Flip the denominator. Okay? Now we need a factor. This is a perfect square. Difference. So the square root of 64 is plus 8 and minus 8. 32, let's see, 32 is going to be 8 times 4. Yeah, we'll do 8 times 4. See if we can go any lower. 16 is 4 times 4. Well, we can make 8. 2 times 4 times 4. So that'll help us out. And then x minus 8 is already done. So now we need to cancel out. So if you look, I've got an x minus 8 on top, x minus 8 on bottom. A 4 on top, a 4 on bottom. 4 on top, 4 on bottom. Smush what you have left, which will be x plus 8 over 2. And that would be your answer. Okay? So you really need to know you're adding and subtracting rational expressions to do these complex ones. Okay? Alright, so number 6 is going to be 4 over 3x all over 6 over 4x minus 2. Okay? So that 2 is over 1, right? So we're going to come over here. 6 over 4x. When we do the keep, change, change. Okay? Now, 4x can't be made to look like 1, but we can multiply 1 by 4x and get 4x. So now I have 6 over 4x plus negative 8x over 4x. I got a common denominator, so I can smush the top. It'll be 6 minus 8x over 4x. So now I have 4 over 3x all over 6 minus 8x over 4x. Keep, change, flip. Okay. So I can reduce this down to see how all the terms, remember I told you all the terms have to have something in common. The 4, the 6, and the 8 can all be reduced by 2, right? So that's 4 over 3x times, divide everything by 2, 2x over 3 minus 4x. Now multiply. That's 8x over 9x minus 12x squared. Now, when you look at it over here, all these terms have what in common? An x. So we can reduce everybody by an x. And it's going to be 8 over 9 minus 12x. Okay? Alright. Number 7. Number 7 is going to be 3 over x squared minus 4 over x all over x over 6. So the top one's not fixed, right? So let's come over here. Let's fix it. We're going to do the keep, change, change. Now, I can't make x squared look like x, but I can make x look like x squared, right? That's just missing an x. So multiply this by an x. Okay, when you do that, you get 3 over x squared plus negative 4x over x squared. Common denominator, smush the top. 3 minus 4x over x squared. So the top is now 3 minus 4x over x squared all over x over 6. Keep, change, flip. Okay. Distribute. 18 minus 24x over multiply x cubed. Nobody has nothing in common there. See, there's no numbers in common. Not everybody has a variable, so that's your answer. Okay? Alright, so I'm going to do one like you're going to see on Delta Math. I'm going to do 2 of them. Alright, so this one you can tell the numerator is not a simple fraction, so we need to make it a simple fraction. Okay, so we come over here on the side. We're going to do the keep, change, change. Now this right-hand side is missing an x, so I'm going to multiply by x over x, and I get 9 over x squared plus negative 3x over x squared, which is 9 minus 3x over x squared. Okay? So we finished the top. Now the denominator also needs work too, so it's 9 over x minus x. We can put that x over 1 just like you do a whole number. I need to multiply this side by x over x, and I get 9 minus x squared. I'll have a common denominator of x. Okay, so now the numerator's right there. Okay, so now it's rewritten as 9 minus 3x over x squared all over 9 minus x squared over x. Keep, change, flip. Keep, change, flip. Alright, now you do have 1x and then 2x, because this 2x right here can be written as x times x. So we can cancel an x out. Okay, cannot cancel those 9's out because they're the whole factor. Okay, as a multiplication, no addition or subtraction. So right now I have 9 minus 3x over x times 9 is 9x. X times x squared is x cubed. And you can't simplify, and that would be your answer. Okay? Alright, so last one I'm going to do with delta math. That's what I want to have. There we go. Alright, so this one also needs work on the numerator and denominator. So let's do the numerator. That is 1 plus 2 over x. We can put that 1 over 1. I can't make x look like 1, but I can make 1 look like x. And I have x plus 2 over x because we'll have the same denominator. So that's my numerator, x plus 2 over x. My denominator, let's go here, is 1 over x. We're going to do the keep, change, change, plus negative x over 4. Now this one, this side needs a 4, and this side needs an x. So it's going to be 4 minus x squared over 4x. 4 minus x squared over 4x. Keep, change, flip. Okay. Now, if you look, I can cancel out my x's, right? Now this guy, I want to talk about this guy. He's not in standard form, is he? You can't factor unless you're in standard form, right? So in standard form, it's negative x squared plus 4. Remember when I told you there's a negative as your leading coefficient to factor it out? So when you pull that negative out, you get that. That's a difference of squares. Square root of 4 is plus 2 minus 2. So this is really negative x plus 2, x minus 2. I can cancel out the x plus 2 and the x plus 2. I'm left with 4 over negative x minus 2. Which, again, please always check your squares. If you need to check your squares, if it's got an x squared, check it in Desmos. Because I had it pulled up on the other browser. Because it was, so this was, what was it? It was so it's 4 minus x squared. It doesn't have to be in standard form. So it's 4. The only thing is you would miss your negative. Okay, but you would have to know. See how, let's see, click. let's see. Never done it with Desmos. Let's see. Okay. So you see how you have a max here? So remember when your quadratic's facing up, it's a positive x minus r, x plus r. If it's facing down, it's a negative x plus r, x minus r. Okay, you would have to know that. So then it would be negative x plus 2, x minus 2. And that would be your factors over here like we did. Okay, so that's your final answer. Alright, so go to Delta Math and you'll find it over there. Okay, alright, bye guys.